Have you ever wondered why a car doesn't suddenly stop or change direction without a cause? Or why do you feel pushed back into your seat when the airplane takes off? To answer these questions and many more, we delve into the world of Sir Isaac Newton and his laws of motion. The first law of motion, often called the law of inertia, tells us that an object at rest tends to stay at rest, and an object in motion tends to stay in motion, unless acted upon by an external force. Imagine a book lying on a table. It's not going to spontaneously slide or fly off, right? It will stay exactly where it is until you, an external force, move it. The same goes for a moving object. Consider a soccer ball rolling across a field. It doesn't just stop abruptly or change its direction on its own. It will keep moving in a straight line until a force like a kick changes its state. The second law of motion explains how the velocity of an object changes when it's subjected to an external force. It's all about acceleration, mass, and force. Picture a skateboarder pushing off the ground with their foot. The force of the push propels the skateboard and rider forward. That's acceleration. But if the rider steps off, the skateboard accelerates much more quickly with the same push. Why? Because the mass is less without the rider. So the force applied causes acceleration, and the mass of the object experiencing the force influences how much acceleration happens. Finally, we arrive at the third law of motion, which states that for every action, there is an equal and opposite reaction. This law explains why you recoil back when you fire a gun, or why you move forward when you push off the ground to jump. When you exert a force on another object, that object exerts the same amount of force back on you, but in the opposite direction. In summary, Newton's first law of motion, the law of inertia, tells us that an object will remain at rest or keep moving at a constant velocity unless acted upon by an external force. The second law, the law of acceleration, states that the force acting on an object is equal to the mass of that object multiplied by its acceleration. And the third law, the law of action and reaction, explains that for every action force, there is an equal and opposite reaction force. These laws of motion, put forth by Sir Isaac Newton in the 17th century, remain fundamental principles in physics. They help explain everything from why sports work the way they do, to how planets orbit around the sun, to why we don't float away when we jump. So next time you see a car speeding down the road or feel the wind against your face, remember, there's more to motion than meets the eye.